Time travel has captivated our imaginations for centuries. From H.G. Wells' groundbreaking novel, The Time Machine, to modern blockbusters like Interstellar, the idea of traversing the fourth dimension has become a staple of science fiction. But is time travel merely a flight of fancy, or could it actually be possible? To answer this question, we need to start with the basics. What exactly is time? Time is a fundamental dimension of our universe, much like the three spatial dimensions we're familiar with. It's the progression of events from the past through the present into the future. But here's where things get interesting. Time isn't as rigid or absolute as we might think. Enter Albert Einstein and his revolutionary theory of relativity. Einstein's work in the early 20th century completely transformed our understanding of time. His theory of special relativity showed that time is relative. It can flow at different rates for different observers, depending on their motion. Let's break this down with a thought experiment. Imagine two identical twins. One stays on Earth, while the other boards a spaceship traveling at nearly the speed of light. When the spacefaring twin returns, they'll find that they've aged less than their Earthbound sibling. This isn't science fiction. It's a real phenomenon called time dilation. In fact, we've observed this effect in action, albeit on a much smaller scale. Astronauts on the International Space Station experience time slightly slower than we do on Earth. The difference is tiny, about 7/1,000ths of a second over 6 months, but it's measurable. Einstein's general theory of relativity takes this concept even further. It describes how gravity can warp the fabric of space-time. Near extremely massive objects like black holes, time slows down dramatically. If you could somehow survive near a black hole's event horizon, you might experience years passing by while only minutes elapse for distant observers. So in a sense, we're all time travelers, constantly moving forward through time at slightly different rates. Theoretical physics suggests several potential mechanisms for more dramatic time travel. Wormholes. These hypothetical tunnels through space-time could potentially connect distant points in space and time. Cosmic strings. These theoretical defects in the fabric of space-time might allow for closed time-like curves, essentially paths through space-time that return to their starting point in both space and time. Tipler cylinders, proposed by physicist Frank Tipler. These are hypothetical, massive, infinitely long cylinders that, if they could exist, might allow for time travel to the past. However, each of these concepts faces significant, perhaps insurmountable, challenges. They often require exotic forms of matter or energy that may not exist, or they'd need to be built on cosmic scales far beyond our current technological capabilities. This is where we run into the famous time travel paradoxes that have puzzled philosophers and scientists for decades. The grandfather paradox is perhaps the most well-known. Imagine you travel back in time and prevent your grandparents from meeting. This would mean you were never born. But if you were never born, how could you have traveled back in time in the first place? Another mind-bender is the bootstrap paradox. Imagine you're a struggling musician who travels to the past and gives your younger self the sheet music for a hit song. Your younger self becomes famous for writing that song. But where did the music originally come from? These paradoxes have led some physicists to propose the Novikov self-consistency principle, which suggests that any actions taken by a time traveler were always part of history, making it impossible to change the past in a way that creates a paradox. So, where does all this leave us? Is time travel possible? The short answer is yes, but with some big caveats. We're all traveling through time, moment by moment, and we know that time can flow at different rates under extreme conditions. In that sense, time travel is not only possible, but an observed fact of our universe. However, the kind of time travel we see in movies, hopping into a DeLorean and zipping back to the 1950s, remains firmly in the realm of science fiction, at least for now. The energy requirements and technological challenges are staggering, and we'd need to resolve those pesky paradoxes. But science is always advancing, and what seems impossible today might be commonplace tomorrow. As we continue to explore the mysteries of our universe, who knows what we might discover about the nature of time? One thing's for certain: the quest to understand and potentially manipulate time will continue to drive scientific inquiry and fuel our imaginations for generations to come. If you enjoy enjoyed this journey through the twists and turns of time travel, don't forget to like, subscribe, and hit that notification bell. And let us know in the comments, if you could travel to any point in time, where and when would you go? Until next time, keep exploring the extraordinary possibilities of our universe.